This video is sponsored by Engineered Labs. Imagine a firework exploding in the night sky, painting the darkness with a brilliant crimson red. Hidden inside that dazzling color is a metal you may never heard of, strontium. On the periodic table, it's marked with the symbol Sr, element number 38, sitting in the same family as calcium and barium. Strontium isn't exactly a household name, yet it has a story that stretches from the depths of Scottish mines to the headlines of nuclear tests. And at the heart of that story lies a spooky question. Does strontium's most notorious isotope really have the power to make you glow in the dark? Could a radioactive version of this humble metal actually turn people luminous? Welcome to Cube Chemistry, where we will discuss all the elements of the periodic system and also do experiments. So if you like this video and want to see more, make sure to like, subscribe and hit the notification bell so you will never have to miss another episode. Also, make sure to fill in the poll in the post section of the channel for next week, as we will be discussing another element again. So here we got strontium in its pure metallic form. It is a soft silvery white metal. When freshly cut, it shines with a bright metallic luster, almost like polished aluminum. But this shimmer doesn't last long. Strontium reacts quickly with oxygen in the air, forming a thin coating of oxide on its surface. The coating dulls the shine and often gives the metal a yellowish or brownish tint. Because of this rapid reaction, strontium metal is usually stored under oil or sealed in containers to keep air and moisture away. Now, the metal itself is quite soft and you could scratch it with a knife. And that brings us to the question, can you lick it? Now, the short answer to this question is absolutely not. Pure strontium metal is dangerously reactive. Your saliva contains water and strontium reacts with water immediately. Now, putting strontium in your mouth would cause it to fizz, burn and release hydrogen gas, essentially creating a chemical reaction directly on your tongue. Now, that could result in serious chemical burns. Even its compounds, while far less dramatic, are not meant for casual tasting. Some strontium salts are safe in controlled medical and dental products like toothpastes, but the pure metal is definitely not something you want to lick. Now, if you want a cube like this or get a subscription so you can collect the full periodic table, make sure to click on the link in the description and use the promo code of our sponsor of today, Engineered Labs, and get a 10% discount, and you will be also helping out our channel. The story of strontium begins in the Highlands of Scotland, in a village called Strontium. In the late 1700s, miners were digging lead, zinc and silver in that area, when in 1787, an Edinburgh chemist named Adair Crawford investigated a mysterious mineral from the mines. He found that this mineral behaved differently from the barium compounds known at the time. Now, Crawford realized that this rock must contain a new kind of earth, the old term chemists used for oxide of unknown metals. Soon after other chemists analyzed the sample, in 1791, Thomas Charles Hope confirmed it was a new element and noted that the compound of this mineral turned flames bright red, unlike barium. The new mineral was named strontianite, after the village of Strontium. And the oxide it contained was called strontia. The pure metal itself was eventually isolated in 1808 by the famous British chemist Sir Humphrey Davy. He used a method called electrolysis, passing electric current through a solution, to split a strontium salt and obtain the metal. Once Davy had the element, he named it strontium, following the naming pattern of its chemical cousins, like calcium from calx and barium from baris, meaning heavy. Interestingly, the name strontium itself comes from the Scottish Gaelic Shron an Tí Senaim, meaning fairy peninsula or fairy headland. So strontium's name carries a bit of a local lore along with science. From then on, strontium entered the periodic table and chemists began to study its properties and uses. Now, in Dutch, stront means shit, and I hoped there was a connection, but it turned out that the name of this element is only funny in Dutch. Now, we've already been through what strontium looked like, so let's take a look at the other properties. Now, like its group 2 neighbors, calcium and barium, strontium has a single common oxidation state +2. In other words, strontium atoms usually lose 2 electrons when they form compounds, creating the Sr+2 ion. Chemically, strontium is quite reactive. It will burn in air, produce a bright flame, and reacts violently with water. For example, if you drop a piece of strontium metal into water, it fizzes and dissolves, producing strontium hydroxide, a strong alkali solution, and releasing hydrogen gas. Strontium also reacts readily with acids, again producing hydrogen and strontium salt. All of this means strontium metal must be handled very carefully in the lab, always under oil or inert atmosphere. In its solid form, strontium is malleable, can be hammered, and fairly ductile, but it's not very strong or hard. One of the most famous characteristics of strontium is the flame color. When strontium or strontium salt is heated in a flame, the flame turns a vivid crimson red. This happens because the strontium atoms emit light in the red part of the spectrum when they are excited by the heat. The red flame test is a signature of strontium and is used by chemists to identify its presence. It also explains why strontium salts are so popular in red fireworks and signal flares, giving them that brilliant scarlet glow. Strontium is fairly common in the Earth's crust, on the order of 360 parts per million, making it about the 15th most abundant element. However, it never occurs as the pure metal in nature. It's always combined into minerals. The two main minerals containing strontium are celestine, also called celestite, which is a strontium sulfate, and strontianite, strontium carbonate. Celestine is usually more plentiful and is mined from the sedimentary rock layers, while strontianite, though rarer, is more easily turned into useful chemicals because it's already a carbonate. Now, these minerals are found in various parts of the world. Today, the largest producers of strontium minerals are in China, roughly 2/3 of the world's supply, followed by Spain, Mexico, and other countries like Turkey and Argentina. In the 19th centuries and the early 20th centuries, Britain, notably near strontium, and later in England and Germany, also mined strontium for industries like sugar refining, but those operations have mostly closed. Strontium is also dissolved in seawater, about 8 milligrams per liter, and many marine organisms like corals and plankton incorporate strontium into their shells or skeletons because it substitutes for calcium in biology. When celestine or strontianate ore is mined, it is processed to make strontium compounds. A common route is to convert the mineral to strontium carbonate, the main commercial form. For example, a black ash process takes celestine and heats it with charcoal, producing strontium sulfide. This sulfide is then dissolved in water and carbon dioxide is bubbled through, causing strontium carbonate to precipitate out. Alternatively, if the ore is strontianate, it can be dissolved in acid or treated with sodium carbonate to directly yield strontium carbonate. Strontium carbonate can be shipped to manufacturers. If the pure metal is needed for specialized uses, the carbonate is heated to form strontium oxide or chloride, and then the oxide is mixed with aluminum and heated. This aluminothermic process produces strontium metal vapor, which is then condensed. Another method is electrolysis of molten strontium salt, but that is less common industrially. Because the metal ignites so easily, most practical applications use strontium compounds rather than the metal itself. Today, reserves of strontium are large, so scarcity is not a concern. Historically, large deposits of celestine have been found in places like Spain, Mexico, and China, where production is on the order of hundreds of thousands of tons of strontium compounds per year. For example, about 300 tons of strontium carbonate or oxide are produced annually. The production roadmap can change as new mines open, but China remains the top producer by far. Strontium atoms can have different numbers of neutrons, which means there are several isotopes of strontium. Naturally occurring strontium is a mix of 4 stable isotopes: strontium-84, 0.6%, strontium-86, 9.9%, strontium-87, 7%, and strontium-88, 82.6%. The isotope strontium-87 is partly special because some of it is produced by the radioactive decay of rubidium-87 over billions of years. Now this means that strontium-87 and strontium-86 rations in rocks can vary and are useful for geological dating. Scientists often exploit these rations by measuring the strontium isotopes ratios in a rock or fossil. They can learn about its age or the environment it came from. Scientists also use strontium as a geochemical fingerprint. For example, archaeologists analyze strontium isotope ratios in ancient teeth and bones to learn where people grew up. The idea is that rocks in different regions have different strontium isotope signatures, which enter the local water and food. A child who eats and drinks locally will have the same signature in their teeth and bones. By comparing the strontium-87 strontium-86 ratio in a skeleton to maps of regional strontium, researchers can tell if a person was local or had migrated from far away. The technique has, for instance, shown that some people buried at Stonehenge grew up in Wales, far from Salisbury Plain. In short, strontium isotopes in bones can act like a natural GPS of the past. Now, beyond the stable isotopes, there are about 60 known radioactive unstable isotopes of strontium. The most famous one is strontium-90. This isotope is not found in nature except tiny amounts from cosmic rays, but is created in large amounts by nuclear fission in reactors and bombs. Strontium-90 has a half-life of about 28.8 years, meaning it takes that long for half of it to decay. It decays by emitting high-energy beta particles, which are energetic electrons, and turns into yttrium-90, which then decays quickly because strontium-90 emits only beta radiation and very little penetration radiation. It's a powerful radiation source, but difficult to detect without instruments. Another radioactive isotope is strontium-89, with a half-life of about 50.5 days. Strontium-89 also decays by beta emission. Interestingly, strontium-89 has a medical use. It is injected to help relieve severe bone pain from metastatic cancer because it acts like calcium. The strontium-89 goes to bone tissue and delivers a targeted dose of radiation to kill or shrink the cancer cells there. This is an example of using strontium properties in medicine. So why is strontium-90 considered scary? Well, chemically strontium is very much like calcium, so living bones can absorb it. Now, talking about calcium, pick it for the next time because we have really cool things that we want to show when we're talking about calcium. Now, if strontium-90 is present in the environment, for example, after a nuclear bomb test or reactor accident, it can enter the food chain and end up in milk, vegetables, and meat. A classic example, during the atmospheric nuclear tests of the 1950s and the 1960s, scientists found measurable strontium-90 in cow's milk and in children's bones. Because strontium-90 lodges in bones and remains radioactive, it can irradiate bone marrow over the years and increase the risk of cancer, such as leukemia or bone cancer. This risk has led to public concern and testing of fallout during the Cold War era. Now, it is important to remember that ordinary strontium, which is the stable isotope, is not radioactive and is essentially harmless at normal levels. The scary label only applies to the man-made unstable isotopes like strontium-90. In everyday life, strontium in soil plants or even in multivitamin trace amounts of strontium-88, say, poses no radiation risk. The danger only arises if one is exposed to high levels of radioactive isotope from fallout or contamination. So let's tackle that big question. Can strontium make you glow in the dark? The answer is no, at least not in any human visible way. Strontium-90 emits beta radiation that we cannot see with our eyes, and it does not produce any light when it decays. In other words, a person contaminated with strontium-90 would not actually emit a greenish glow like something out of a movie. The idea of a glowing person comes from the older stories about radium and other luminescent materials. For example, early 20th century radium paint on watch dials did cause a faint glow and also sadly caused health problems for the painters, but strontium-90 itself does not cause such a glow. Now, there is a real glow related to strontium, but it works differently and is entirely safe. Modern glow-in-the-dark paints and toys often use a compound called strontium aluminate, doped with tiny amounts of rare earth elements like europium and dysprosium. These phosphorescent materials absorb light, sunlight or UV, and then slowly re-emit it as visible light over hours. The glow is usually greenish or bluish and can last for a long time, making things like stars on bedroom ceilings or watch faces glow softly at night. This glow happens because of the material's chemistry, not because of any radioactivity. In fact, strontium aluminate pigments were developed to replace older radioactive glows, like those containing radium or tritium. So yes, strontium compounds can be part of glow-in-the-dark materials, but is a completely different mechanism from nuclear radiation. One more possible source of confusion is Cherenkov radiation, a faint blue light seen in nuclear reactors. This light occurs when charged particles, like beta particles, move faster than light can travel in water. If you had a large source of strontium-90 submerged in water, you might see a faint blue glow. That is Cherenkov radiation. However, that effect requires high radiation levels and transparent medium like water or glass. It certainly wouldn't make a person glow in air. In normal environments, strontium-90 does not cause any visible luminescence. So, to repeat, no, strontium's scary isotope will not make you glow in the dark. Strontium is better known for its practical uses in everyday life than for its radioactivity. One of the most common uses is in pyrotechnics and flares. Strontium salts give fireworks and signal flares their bright red color. Fireworks manufacturers add strontium carbonate or strontium nitrate to achieve vivid crimson bursts. If you've watched a fireworks show and seen those deep red fireworks, that's often thanks to strontium. Road flares and marine distress flares also rely on strontium's color. Its ability to color flames red is unmatched by most other chemicals, which is why strontium is essential for those intense reds in celebratory displays. Another historic use was in the glass of old color television and computer monitors, CRTs. When the electron beam scans a CRT screen, X-rays are unavoidably produced as a byproduct. Strontium compounds, added as strontium carbonate in the glass, absorb these X-rays, preventing them from escaping the tube. This made early color TVs safer for viewers. With the advent of LCD displays, this use has declined, but for decades it was a major industrial use of strontium. Strontium also appears in materials engineering. For example, strontium ferrite magnets made from strontium carbonate and iron oxide are used in small motors, loudspeakers, and fridge magnets. These ceramic magnets are inexpensive and use strontium to achieve strong magnetic properties. In metallurgy, tiny amounts of strontium are added to aluminum silicon alloys, common in car engine parts, for example. Strontium modifies the structure of the alloy as it solidifies, making the metal stronger and easier to machine. Some industrial processes use strontium too. Strontium compounds help in zinc refining and pigment production. For instance, strontium can bind with impurities in molten metal, aiding in their removal during refining. Strontium is also used in making special ceramic glazes and bricks, improving durability and color. These uses are more specialized, but they take advantage of strontium's chemistry to solve practical problems in manufacturing. In the chemical industry, strontium compounds have niche roles. Strontium oxide is used in some optical glass and in certain lab reagents. Strontium peroxide was once used in signal flares and as a bleaching agent in sugar refining. Strontium chloride is found in some toothpaste for sensitive teeth. It works by blocking the nerve signals in tiny tubules of tooth enamel, reducing sensitivity to hot or cold. Strontium sulfate is used in screw-type deep-sea ports and air drying in cosmetics due to its insolubility. In research, strontium is a handy tracer. Geologists use strontium isotope ratios to date rocks and understand Earth's history. Environmental scientists sometimes release a non-toxic strontium isotope to track where water flows or how materials move. One particularly interesting application of radioactive strontium is as a power source. Because strontium-90 generates heat as it decays, engineers have put it into radioisotope thermoelectric generators, RTGs. These devices convert decay heat into electricity. Plutonium-238 is more famous for NASA missions, but strontium-90 RTGs were used in Soviet-era satellites and lighthouses. For example, the Soviet lunar rovers, robotic vehicles on the moon, used strontium-90 heat sources to keep their electronics warm during the freezing lunar night. Strontium-90 RTGs have also powered remote beacons and unmanned weather stations on Earth. Especially in the USSR, the heat from a few grams of strontium-90 can keep small instruments running for decades without sunlight or batteries. There's also a minor use of strontium in some pigments and glazes. Strontium chromate, for instance, was used as a corrosion-resistant yellow pigment in primer paints, though environmental concerns have reduced its use. Some high-temperature cement and glaze formulas include strontium for stability. Again, these are niche, but they show that strontium's chemistry has been harnessed in many ways. So how dangerous is strontium? Well, the answer depends on the form. Stable strontium, the normal kind found in rocks and minerals, is not highly toxic. In fact, it has no known essential role in the human body, but in small amounts, it's generally harmless. We absorb only tiny amounts of dietary strontium from plants, grains, and water. And most of it is simply excreted. About 99% of strontium in a person's body ends up in bones and teeth mixed with calcium. At typical environmental levels, strontium behaves like calcium and is not considered a significant poison. However, like any alkaline earth element, strontium compounds can be irritating. For example, strontium hydroxide, from contact of the element with water, is a strong base and will burn skin or eyes on contact. Strontium salts used in fireworks, like strontium nitrate, are oxidizers and should be handled carefully to prevent accidental ignition. Strontium metal is very dangerous. It ignites spontaneously in air and reacts explosively with water. So chemists always handle it under oil or in a sealed glove box. But these are laboratory concerns. The average person will never encounter pure strontium metal. Because of its similarities to calcium, strontium naturally accumulates in bones. Some marine organisms and corals even use strontium as they build their skeletons, sometimes preferring it over calcium. But for humans and land animals, strontium is essentially just a stand-in for calcium. This underlies both its medical use, like strontium renalate for bone loss, and its hazard if radioactive. The truly hazardous form is radioactive strontium-90. If strontium-90 is ingested or inhaled, the body will deposit it in bones, just like calcium. Then, as strontium-90 decays over the years, its beta radiation can damage bone marrow and induce cancer. This is why exposure to strontium-90 is strictly controlled. In nuclear accidents, for instance in Chernobyl in 1986 or Fukushima in 2011, one of the pollutants tracked in the environment is strontium-90. food, milk, and water are monitored, and authorities will remove contaminated soil or ban certain foods if levels are too high. Over time, strontium-90 decays away. Its half-life is 29 years, and cleanup efforts can remove it, but it remains a worry for decades. In day-to-day life, away from nuclear incidents, strontium-90 in the environment is usually extremely low. The small amounts left over from the past nuclear tests or fallout are generally not enough to harm a person. Ordinary strontium in your diet or in the soil is not something to worry about. You won't glow or vibrate or anything like that. The best advice is to be aware of radiation in general. Not specific to strontium, if you live near a nuclear power plant or if there has been a known release. But simply handling strontium compounds in industry or seeing strontium on a label is not a hazard in itself, unless it's specifically marked radioactive. Now, the sponsor of today's video has been with us since the very beginning of this channel, and for a good reason. Imagine having a miniature museum of chemistry delivered right to your door, 1 cube at a time. That's exactly what Engineered Labs Cube subscription offers. A curated journey through the periodic table, month after month. With this subscription, you're not just collecting random cubes, you're building a complete periodic table. You can choose the 82 element International Edition or the 85 element US version, each featuring real elemental samples safely sealed inside crystal clear acrylic cube, like you've seen on this channel. Perfect for students, teacher, or anyone who just loves science, these cubes let you actually hold the building blocks of the universe. And here's the best part. As your collection grows, you'll end up with a stunning display. Whether it's on your desk, your wall, or classroom, it's both decorative and deeply educational, turning the periodic table into something you can see, touch, and truly appreciate. So, if you want to inspire curiosity, spark learning, or simply own a piece of chemistry history, check out Engineered Labs Cube subscription today, with 82 elements internationally or 85 here in the US. This is your chance to own the periodic table 1 cube at a time. And if you use our promo code, CubeChemistry, you will get a 10% discount. Strontium may have a mysterious sounding name and a scary isotope, but in most ways it is an ordinary player in our chemical world. It's a soft, reactive metal that gives firework their stunning red color, and it once protected TV viewers from X-rays by hiding inside the glass of old televisions. Most of the strontium around us is locked in minerals or dissolved in seawater, quietly present in sand, soil, and even our bones, along with calcium. Its radioactive isotope strontium-90 is indeed hazardous when released into the environment. However, even that isotope won't make you glow in the dark. It's dangerous only because of its invisible beta radiation and its affinity for bone. The idea of strontium turning people into glowing specters is a myth. Instead, strontium finds a place in many beneficial uses. It helps color our celebrations, it aids medical treatments for bone pain, it even provides clues to ancient human migrations. We would like to thank the members that support our channel. Thanks for doing this, we really appreciate you. Now, if you think we missed anything, tell us in the comments, and if you want to know more about another element that is used in fireworks, make sure to watch this episode of Magnesium next.